Hello everyone, my name is Christopher Reyes, and today I'm going to walk you through how our brain learns, how it stores information, and why the hippocampus sits at the center of this entire process. My goal is to make the science approachable for everyone, but still accurate, and to connect these ideas to the way that we live, study, and make sense of our experiences. By the end of this talk, you'll be able to do four things. My learning objectives for everyone are to first understand how learning and memory actually work in the brain, not just the definitions, but the processes behind them. Second, explore why the hippocampus is so essential, especially when it comes to forming and organizing new memories. Third, differentiate key types of memory so we can see how they function differently in our lives, real life. And finally, we'll connect learning to brain plasticity, the idea that the brain is constantly reshaping itself based on our experience. So, what is learning? Let's start with this itself. At its core, learning is simply the brain adapting to new experiences and new information. We often think of learning as something that happens in a classroom, but it's actually a biological process. Every time we practice a skill or revisit an idea, certain patterns of brain activity strengthen. Repetition isn't just a study strategy, it's a physical change in how our neurons communicate. And over time, neural connections shift and grow. Some pathways become stronger and more efficient, while others fade if we don't use them. So learning is really the story of constantly adapting our brains. Now for the key types of memory. To understand our learning, we also have to look at memory. Not all memory works the same way. It's actually a set of different systems. We start with sensory memory, which is extremely short-lived. It takes in raw information from the world, sights, sounds, our sensations, just for a moment. Next is short-term versus long-term memory. Short-term memory holds a small amount of information for brief periods, while long-term memory stores what really matters to us across hours, years, and sometimes an entire lifetime. We also divide memory into explicit and implicit types. Explicit memory is what we consciously recall: facts, stories, and events. Implicit memory, on the other hand, includes habits and skills we perform automatically. And holding all this together is consolidation, the process that stabilizes long-term memories and makes them durable. This is where the hippocampus really starts to shine. The hippocampus is small, but its impact is colossal. One of its most important jobs is forming and organizing new memories. Without the hippocampus, we can still remember our past, but we struggle to form new long-term memories. It also gives our experiences context and meaning. The hippocampus helps us remember not only what happened, but where it happened, when it happened, and how it felt to us. And interestingly, it also supports navigation and spatial awareness. Whether we're remembering the layout of a new building or mentally retracing our steps, the hippocampus is always working behind the scenes. Now, let's bring this together with brain plasticity. Brain plasticity, or neuroplasticity, describes how experiences reshape our neural networks. Learning literally rewires the brain. Every new skill, memory, or habit changes the pattern of activation among our neurons. The hippocampus supports flexible thinking by helping us form new associations and connecting new information to old knowledge. It's part of what allows our brains to adapt instead of getting stuck in rigid patterns. And repetition builds stronger pathways, which is why consistency matters so much more than intensity when it comes to studying or practicing. The more we revisit something, the more natural it becomes for the brain to store and retrieve it. Now, why does this matter? Why does any of this matter for us today at that? Understanding how learning works explains why our memory strengthens or weakens over time. Memories don't just fade away. They depend on how often we revisit them, how meaningful they are, and how the brain organizes them. This knowledge also helps us improve our learning and study strategies. Techniques like spaced repetition, sleep, and connecting new information to prior knowledge aren't just some random tricks, but they align with how the hippocampus and the broader memory system actually operate. Finally, knowing how the hippocampus works can deepen our understanding of memory disorders like Alzheimer's, trauma-related memory disruption, and amnesia. These usually start with the hippocampus and problems within it. By studying this structure, we learn not just how memory works when everything goes smoothly, but what happens when the system breaks down. And of course, it is very, very cool. Thank you, everyone, and there's my references.